Okay, so we're going to do inferences about means, and it's kind of using t-tables here. Okay, so they've given us some formulas here. We got to talk about them and when we use them. So this is called the one sample t interval for population means. So we have y bar here. Y bar stands for a sample mean. Okay, so y bar is a sample mean. So that means they've given us a few pieces of data and we take our sample. And we've done X bar for sample means before. But the reason you're using Y bar is because when we're doing t intervals, we're actually using small amounts. So these are for very small amounts, things that aren't, I guess, statistically significant. And the reason we use t-charts is they've done some studies and they discovered that they'll essentially, this guy developed them so that they kind of make things normally distributed. It's a really long process. You'll have to read it in your book. But the idea is we use the t-charts for small samples because to find normal distribution, usually we need very large amounts of information, right? Very large amounts of data. But say we only have 6. We've only done 6 trials. Well, you might have a histogram that looks something like this, maybe. Okay, and then maybe over time it would eventually become normally distributed, right? And starting to get there. But with 6, it's not easy to see. So they use t-charts to help us out with this so that we can be a little more accurate, okay? So this is a sample mean for a small trial. And what it says is you plus or minus t asterisk n minus 1, okay? And that stands for the critical value in the t-chart. So we have to learn how to look things up in a t-chart using n minus 1 degrees of freedom. Well, n is the number of trials, right? And we're going to practice looking that up too. I have a chart for us to look at. And we have to multiply that by the standard error of the sample mean. Okay, well, the standard error of sample mean is equal to the standard deviation divided by the root of the number of trials or data. Okay, so this formula here and this formula here are important for what we're about to do. So I just give us some very basic information here. Okay, so they've told us we have 23 trials, our mean is this number, our standard deviation is that number, and then what they'll normally say is what confidence interval you're going to find things at. Okay, and in this one, they're going to say at 95% confidence. Okay, confidence interval, so CI. And we're going to talk about that after because you can find things will vary depending on what confidence interval. In fact, on top of that, we'll do a 98% confidence interval also. So we'll do an A and a B. Okay, so our N in this case is 23. We have 23 trials. Our Y bar, which is our mean, okay, or our sample mean is 756.22, and our S, which stands for our standard deviation, is 107.12. Okay, so our formula here states that what we're going to do is we're going to take the sample mean and we're going to add and subtract from it. Okay, and what this is going to do is give us a range. We're going to have a high and a low point. And what we say is our mean is somewhere in there. With normal distributions, we usually have an exact mean. But because we only have such a little amount of data, we have to give a range to where we're pretty confident the true mean falls. We can't tell you exactly where it is because we don't have enough information, but this helps us estimate where it will be. Okay, and that's going to be t, right? T asterisk n minus 1 degrees of freedom multiplied by the standard error of that. Okay, so what does that all mean? Well, we know our y bar, so we can plug that information in. We have 576.22. 756, sorry, 0.22 plus or minus. I'm going to leave this right now. It's still going to be t, but in this one it's going to be 23 minus 1, right? That's going to be our degrees of freedom. We've plugged 23 in, and I guess I should do that in green so we can color reference it. 23 minus 1, because that's our n. And it's going to be multiplied by, well, let's actually calculate our standard error. Standard error, remember the formula for this was standard deviation over the root of n. Okay, well, let's calculate this on the side. The standard deviation was 107.12 divided by the root of 23. So our standard error in this question is divided by, you have to put a second square root. Oh, that's the cubed root. Second. Oh, no, you don't need a second. Square root of 23. It's 22.33. Okay, so 22.33. So we're multiplying by 22.33. But I still don't have this number. This represents some number. Well, what is that going to be? 23 minus 1, we're really going to be looking up t at 22 degrees of freedom. So I have a picture here of a t-chart. I know it's not great, okay? But we were going to focus on, first of all, look at the bottom here. I know it's a bit cut off, but that's 90 degrees of freedom, okay? This represents 95. This is 98, and this is 99. And another way you can tell is going up to here. You see that number 0.05? That's how much we subtract from 100.
Oh,
okay, so that tells us it's 95. The one to the right of it is 98. The one to the right was 99. And the one to the very left, well, it's 0.2. That actually represents 80% confidence intervals. We try to be confident with what we're doing. So then degrees of freedom. You look to the left, and it's right there, DF. And we're looking for how many degrees of freedom in our question?
22.
22 degrees of freedom. So we'll scroll down. Now, luckily, they actually have 22 on here. If you go towards a little farther down, look around 15, 60, you might get something like 55 degrees of freedom, but we don't have a value for that, right?
Mm-hmm.
So what we'll do to be conservative so that we know our answer is true, we'll go to the higher number because that will give us a larger interval, which means it's more likely that it's going to fall in there.
Oh.
Now, luckily on this T-chart, we have it, right? 22 we said?
Yep.
So 22 at 95, what's that number we're looking at?
It's 2.074.
2.074. So we're going to replace this with 2.074 times our 22.33 and plus or minus the 756.22. Okay, so let's figure out what our plus or minus is. We take out our calculator and calculate that. 2.074 times 22.33, assuming we did that right, 46.31. 46.31. Okay, so we have 6.22. Okay, so now what this is saying is we have to add and subtract this amount from here. Okay, so we're going to have a high value and a low value. So this will be our low value and this will be our high value. And we add that amount to this to figure it out. And did you do that?
The high value is 802.53.
802.53, and the low value 7. I think it's 09.9, something like that. And I'm just going to write down what you're doing. So on the side here, so we're doing 576.22 plus 46.31. Okay, and what was your low value? Was that the right low value?
Yep.
Okay, and you did 576.22 subtract 43.31, and it's like, think of it like standard deviations. This is just a range of answers, right? So 709.9. So what we just figured out here, this is our low and our high. How do we say this? Well, we say we are 95% confident that the mean, okay, so the true mean falls between 709.9 and 802.53. So we didn't get the actual mean, but we got, a range of it. Okay, so we got our range, which helps us figure out or gives us a better idea of what we're probably looking at, and that's with 95% confidence. Oh, we said we were going to do 98. I'm not going to zoom out yet. Okay. Well, luckily, a lot of the information is still the same, right? The only real difference here is going to be this number, right? So if that's true, let's find our new confidence interval here. We know we still have a mean of 756.22 plus or minus, and the standard error was still 22.33. So we need to find at 98% confidence. I'm going to bring up that picture again. So according to this, at 98% confidence, which is the next one over at 22, we would multiply by 2.508. Is that right?
2.508. Oh, you multiply by 2.5?
Well,
oh,
yeah.
No, you multiply. Oh, okay.
You multiply that value by it, right?
Oh, yes.
So now we have 7, and can you help me out and do that? Or actually, I'll do it also. And then you just give me the high and low. Did you get 56 pretty much? I'm just going to round it to 56. Okay?
Did that wrong.
I think that should be right. Try it again. Let's double check. I think we got 56, so you're going to be my double check. Which means our range for our low is going to be 722 on our low. And our high is going to be a little higher. Plus 812. Assuming we've done this correctly, okay, assuming I calculated that part there, notice our high and low are a bit larger. Okay? Our other numbers were 802 and 709. These ones are 812 and 700. So giving us a bigger range. In other words, we're kind of, well, what we're saying is in order to be 98% confident, we have to give ourselves a larger range, right? So the more confidence goes up, the larger we have to make our range, just like 3 standard deviations, right? When we're 3 standard deviations away, there's a lot more information in there, so we can say, yeah, it's for sure within that amount, but it might not be.
Okay.
So the closer we are to a certain value, the less confident we can be, because we may have made errors, or maybe we just don't have enough information in the end. Okay? So does that idea make sense?
Yeah.